Hello, everybody. So we will be doing gear trains today, or gears. Okay. So before that, okay, let us take a look at the technical terms that we use. Okay, the first one is pitch circle. Now, pitch circle is an imaginary circle which, by pure rolling action, would give the same motion as an actual gear. Okay, so usually we don't need to draw the shape of the gear when we are solving problems. What we do is we just draw a pure circle and assume that that pure circle will give us the same rolling action as the actual gear. Okay, and then the diameter of the pitch circle is denoted by the symbol of D. Uppercase letter D or lowercase letter d will do. Okay, the second term is called the circular pitch. It is the distance that we measure on the circumference of the pitch circle. The circumference of the pitch circle from one point of a tooth to the next point of the neighboring tooth. Okay, now, and it is usually denoted by the symbol of P with a subscript of C. Mathematically is written as pi d over t, where d is the pitch circle diameter and t is the number of teeth on the gear. Okay, now a little consideration will show that the two gears will mesh, any two gears will mesh together correctly if the two gears or the two wheels have their same circular pitch. When they have same circular pitch, only they can mesh, that means come into contact correctly. Okay, so note that if D1 and D2 are the diameters, that means the pitch circle diameters of the two meshing gears having teeth of T1 and T2. Okay, so D1 and T1 belongs to gear 1, D2 and T2 belongs to gear 2. So the ratio, that means the circular pitch of both the gear must be the same in order for them to contact correctly or to mesh correctly in place. Okay? So therefore, when you look at this equation here that I have written, so the circular pitch for both the gear, this you can call it as PC1, and this we can call it as PC2. So when you look at the pi, you can clean it up. So you have D1 over T1 equals to D2 over T2. When you rearrange this, you have D1 over D2 equals to T1 over T2. So that means it shows that the larger the diameter, that means the larger the circle or larger the gear, the number of teeth on the gear should be more. If let's say, for example, the gear is smaller or the pitch circle diameter is smaller, then the number of teeth is lesser. So that means the diameter, the pitch circle diameter of the gear, excuse me, the pitch circle diameter of the gear is actually directly proportional to the number of teeth. Remember that. Larger gear, more teeth. Smaller gear, lesser teeth. Okay? So then the third term is the diametral pitch. It is the ratio of number of teeth to the pitch circle diameter in millimeters, and usually is denoted as P, stands for the pitch, and D is diametral. So we call it as diametral pitch, and it is written as, okay, D over T actually. So then the next one, that is the module, okay? So module, it is the ratio of the pitch circle diameter in millimeters to the number of teeth. Module is written as D over T. So the pitch circle diameter to the number of teeth. This is called the module. Okay, so these are the terms that we usually use in gear trains or in gears. Now, simple gear train. So you can see I have two diagrams. Okay, the first one you can see, okay, this blue gear and this is an orange gear. You can call any of these as the driver. So if you, let's say you choose the orange gear here, the orange color gear is the driver, then the motion of the gears will be from this, the orange color gear, to the brown color, and then to the blue. Okay, if let's say you choose the blue to be the driver, then the direction of motion should be from the blue to the brown, and from the brown to the orange gear. Okay, so it depends on which one you choose to be the driver. So if let's say you choose blue to be the driver, then the orange one should be the last driven gear. Driven and driver. So here, what is the difference between these two arrangements? So here you've got one intermediate gears, or auxiliary gear we call. Okay, here you have two intermediate gear. So usually is counted by odd or even. So odd, let's say you have 1, 3, 5, 7, 9. Even you have 2, 4, 6, 8, 10. So you can have odd or even. It depends on the direction of motion that is required between the first driver and the last driver. So when you look at the first diagram here, let's say the blue one is the driver. So and then it is rotating in clockwise direction. So if this is rotating in clockwise direction, then the brown color should be rotating in anti-clockwise. So if the orange color is rotating in anti-clockwise, then the orange one will be rotating in clockwise. So you can see that both the first and the last, so we call it as the first driver and the last driven, they are in the same direction if you use odd even. Okay, sorry, odd number of intermediate gears, that means 1, 3, 5, 7, 9. So if you are using even number of intermediate gears, let's say 2, 4, 6, 8, then the direction of rotation between the first gear and the last gear would be opposite. So bear in mind. So whether to use odd or even, okay, we have to look into whether the input and the output, we want it to be in the same direction or opposite direction. If we want the input and the output to be rotating in the same direction, then we should put odd number of intermediate gears. If let's say we want the input and the output to be rotating in opposite direction, then we will put even number of intermediate gears. So here, this is called the train value, the train value. So we usually use formula as stated here. We use speed of driven gear, that means in RPM or in RPS. That means in revolutions per minute or in revolutions per second. The speed of driven over the speed of the driver or the driving gear. So when you look at this, this is driven over driver. So on the number of teeth, you should put driver over driven. Because the speed and the number of teeth, they are always inverse. Okay, inverse, that means opposite. Because larger gear, number of rotation or number of revolution is lesser. Smaller gear, the number of revolutions or the number of rotation that it makes is more. Okay, so that is why it's opposite. So let's say I put driven over driver. So the number of teeth should have driver over driven. If this side I put driver over driven, then the other side should be driven over driver. Okay, so it's always opposite between the speed and the number of teeth or the pitch circle diameter. Because we know that number of teeth and pitch circle diameter, they are proportional. And also, in addition, we must put a negative sign here. Because when we consider this, usually, if let's say, for example, I consider this as the input and this as the output, so what happens is the motion of this gear will be transferred to the next gear that is an intermediate gear. So this will be the driver and this will be the driven. So between two neighboring gears, they always rotate in opposite direction. So that is why it's always a negative sign that it is written here. So if let's say, for example, you consider between the brown gear and the orange color gear, they will also rotate in different direction. So that is why if let's say this is chosen to be the driver, then this will be the driven. So bear in mind, the train value, when you write down the train value, this should be in terms of N, which is in RPM or RPS, N of driven gear, and N of driver gear is equals to T of driver gear over T of driven gear, and a negative sign beside if they are rotating in opposite direction. If let's say, for example, you refers to the first diagram or the second diagram, usually the neighboring gear, they are rotating in opposite direction. So that is why that is a negative sign here always. Okay, so let's say, for example, we work out the train value for this system here. So the first step is we choose between the neighboring gears. One is the driver, and this one to be the driven. That means the blue is driver, the brown color is the driven. So I name this as second gear. I name this as the first gear. So you have the driven speed, you see, I put here N2, over the driver speed, you see here, I put N1. And then equal, negative sign, always put a negative sign. And then you can see, this is 2 to 1, so here you should put 1 to 2. If you put here 1 to 2, that means N1 over N2, here you should put T2 over T1. So if let's say, for example, you know the speed of the driving gear, the input gear. So if you want to find the speed of the intermediate gear, you can always take N2 to be the subject and bring N1 over to the other side to form an equation like that. So it's easily, you can easily find the speed of the driven gear like this by knowing the number of teeth of both the gear and the speed of the move on until you finish the whole the whole transfer motion. So the next one will be the brown, between the brown and the orange, because here we have input and this is output. So that is why we have to work through from blue, brown to orange. Okay. So these two gear, this will be the driver now, and this will be the driven. So what you can do is, this is, you can name this as gear 3, and you can name this as gear 2. So since it is driven over driver, you see N3, that is driven, speed of driven, over the speed of the driver N2. And then you can see I put a negative sign here again. So remember, if this is 3 to 2, then this should be 2 to 3. Okay? So if let's say, for example, we want to express the speed of the driven gear, so that is N3, that would be our subject. So N2, you bring it over, so you have this equation here. And then actually you can join both these equations, can join up both of these equations to work out the speed or the train value between the first and the last. So what you need to do is you just substitute N2 here, which is equals to this, into this equation here. So you will get N3 in terms of N1 actually. Okay. So from here, I will show you, okay, the way the gears rotates. Okay. So before that, okay, take note, negative sign refers to the opposite direction of rotation between two gears. Number of intermediate gears does not affect the speed ratio. Remember, any numbers, you use 1 or you use 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10, the speed ratio between the first and the last will always be the same, no matter whether you use odd or even. The only thing that is being affected is the direction of motion between the first and the last. Okay, when you consider odd or even. So I repeat this again, number of intermediate gears does not affect the speed ratio between the first and the last gear. It only determines the direction to which it is meant to be. Okay, so you want it to be in same direction between the in and the out, or different direction between the input and the output gear. Now, when the distance between the two shafts is small, if the distance between, usually the input gear is attached to the input shaft, the output gear is attached to the output shaft, and they lie parallel to each other. So this simple gear train is used only when the shafts are lying parallel to each other. So here I got 3 examples. Okay. So when the distance between the two shafts is small, The two gears 1 and 2 are made to mesh with each other to transmit the motion from one shaft to another, as shown in the figure, this one. Since the gear 1 drives the gear 2, therefore gear 1 is called the driver and gear 2 is called the driven or the follower. Now, it may be noted that the motion of the driven gear is opposite to the motion of the driving gear. So if the distance between the driver and the driven is quite far away from each other, we can actually put in what we call auxiliary gear or intermediate gear, which will not affect the speed ratio between the driver and the driven, but only will affect the direction of motion. So you can see, now if the first gear rotates in clockwise, then the next will be in anti-clockwise. That is for this. Okay, for the second set, if this is rotating in clockwise, then this will be anti-clockwise. Then if this is anti-clockwise, then this will be clockwise. So you can see both these gears are rotating in same direction if you use odd numbers. Now the third set, you can see this is rotating in clockwise. This will be anti-clockwise. This will be clockwise. This will be anti-clockwise. So the direction of rotation between the input and the output is in opposite direction. So it depends on what you want. You want same direction or you want opposite direction. So you have to choose whether you're going to use odd or you're going to use even. But then it won't affect the speed ratio between the gears, between the in and the output shaft. So the next one is called, okay, so we still have simple gear train here. I'm showing you how they work, okay, in the larger arrangement. So that is my mistake because I can't mesh them. Actually, they should mesh. Okay, so here I have worked out as what I have told you. If let's say it refers to the first set, A is the driver, B is the driven, you will have something like this. So NB over NA equals to negative TA over TB. So if you want to find the speed of NB, then you change that to be the subject. Then you have equation 1. Okay, then for the next one is between B and C. So we will work out the driven over the driver. So NC over NB, negative TB over TC, always opposite here between them, between the speed and the number of teeth. So if you want the NC to be the subject, then you should bring your NB over. So if let's say, for example, you want to find the speed ratio or the train value between the first and the last gear. So what you can do, you can substitute equation 1, which you have NB into this. So you have this equation here, and negative become positive. That means it shows that the gear A and the gear C, they are rotating in the same direction. Okay, so you have something like this. So it won't affect the speed ratio, okay, even you use odd or even. So the next one is called a compound gear train. So why it called a compound gear train, you can see this gear, these two gears here, actually they are mounted on one single shaft. If these I call as input, then this one should be output. If I call this as input, this should be output. Why it's known as compound, you can see both these gears, I repeat once more, both these gears are attached or mounted on the same shaft. So that is called a compound gear train. Okay. So the pitch circle radius, the R here stands for pitch circle radius. So the pitch circle radius of gear A and gear B here, you can add them up, you can get the center to center distance here. And for between this gear and this gear, that means C and D, so you can add them up to get the center to center distance as well. But then remember, okay, these two gears, they are mounted on the same shaft, so their speed is the same. But when you look at this, RA plus RB will not be equals to RC plus RD, okay? Then the next one is called this is compound gear train, yeah, side view. The next one should be, okay, you can work out this. This is called the train value or speed ratio. You can see for compound gear train, the speed ratio is actually affected by how they are arranged, and then it is modified by it, you can see this number of teeth are included. So the previous one, which we call simple gear train, they are not affected by the number of teeth. That means any amount of intermediate gears. But compound gears, it is being affected by the number of intermediate gears. So you can see the relationship between the last gear and the first gear. It is affected by this, okay, the C and B teeth, okay, C and B. So that is compound gear. Okay, remember speed ratio is being affected, but then for simple gear train, it's not being affected when you use odd or even intermediate gears. But for reverted gear train, you can see if this is input, that this should be output. And this should be a compound gear where both these gear actually they are mounted on one single shaft. This is my mistake here. Okay, both these gear are mounted on the same shaft. It is called compound reverted. Okay, why? You can see RA plus RB, and this is RC plus RD, they are equal. Where compound gear train is not necessarily equal. But for reverted, this must be equal. And usually we call them as compound reverted gear train. Okay, so this distance here, where you have RA, pitch circle radius of gear A, plus pitch circle radius of gear B, must be equal to the pitch circle radius of gear C plus the pitch circle radius of gear D. They are the same. That means the center to center distance must be the same. And these are usually used in compact design. Compact gear train design, let's say, for example, most of the watch, WATCH, watch mechanisms, okay, mechanisms, where they will need very compact design. So that in the compound reverted gear train are being introduced. Okay, so this is how they are being arranged. Okay, so when you work out the speed ratio, they should be the same. Okay, so that's for this part. Okay, the first part. Okay, we will continue with the next slide later. Okay, thank you very much. And I still have to say, stay safe and always wear your mask. Okay, thank you. Bye bye.